Hi, and welcome to the video on Power Rules. This video and the notes are designed to help you prepare for an upcoming lesson on multiplying polynomials. So let's begin. First off, what are power rules? You probably already know this, but power rules are the rules you use when dealing with exponents. Let's look at a few quick examples so we can see how and why these rules actually make sense. Let's start with addition and subtraction. So if we take something like 3p plus 4p, where let's say the p is actually representing pigs, so we're adding 3 pigs and 4 pigs together, we know that's going to give us 7 pigs. And mathematically, the way that we can think about this is we can take those 3 p's, those 3 variables, and just break them up, separate them by plus signs, so we're representing this as the 3 p's, and then add to that another set of p's where there are 4 p's separated by plus signs. And if you counted all of those p's, you see that there would be 7, which will give us 7 p's or 7 pigs. Now we have to remember when adding or subtracting variables that we must consider like terms. For addition and subtraction, like terms are terms that have the same variable raised to the same exponent. Let's look at a couple non-examples. So if we have something like 3 pigs and 2 horses, they're not the same. So 3p and 2h are not the same because they're different variables. And so when you combine those together, nothing happens. You essentially have 3 pigs and 2 horses. Likewise, if you take something like 2s squared plus 2s cubed, where let's say s squared is the area of 2 squares, and s cubed is the volume of 2 cubes. When you combine those together, again, they stay as 2 squares and 2 cubes. You can't combine them because they're not like terms. In this case, even though the variables are the same, the exponents are different. For multiplication and division, we can think of it this way. So if we had something like 5x to the 4th power times 6x to the 7th power, just like we broke down the p's up here, we can kind of break this down. This is actually called factoring. So we can break those two terms down and we would get 5 times 4x's all multiplied by themselves, right? So 5 times x times x times x times x, and that's being multiplied by 6 times x times x times x times x times x times x times x. And when we're looking at that, we know that 5 times 6 is going to give us 30. Everything here is all being multiplied together. Now there are 11 x's here, so there are x is being multiplied by itself 11 times, which gives us x to the 11th power. So for our coefficients, they multiply, and for, notice the exponents or the powers here, they add. So again, this should all make sense to us. And we can look at another example where we have 2 types of variables here. Same thing will happen where we can break it down and we can multiply our coefficients and then count up the number of variables. In this case, we have again 4 x's and 11x and 7 x's all being multiplied together, so that's 11 x's being multiplied together, so x to the 11th power, and we have 1 y and 2 more y's being multiplied together, so that is y to the 3rd power. So in total, we would get here 30x to the 11th times y cubed. So as we see, the power rules make sense, and that's not the issue that most of us have. The issue that most of us have is memorizing these power rules when we're needing to use them. So when I was in middle school, I had this bright idea for power, well, it wasn't that bright, but anyway, I did have an idea for memorizing power rules, and it was this thing I like to call an operations pyramid, which is up here. So this is where you're going to begin taking the notes, and you're just going to label that operations pyramid. And the way that this pyramid works is that I kind of divided the operations into a pyramid where at the base there was no operations, so it's the most basic, like nothing is happening. And then the operations, addition and subtraction, those are the easiest operations that I know. and then the more complex, multiplication and division, and then powers and roots. So as you see, the way that the pyramid is going, as you go up in the pyramid, the complexity of the operation increases. You'll also notice that on the left side of the pyramid, we have the types of operations like addition, multiplication, and powers, which typically increase the value. So if you're adding something, your numbers are getting larger. When you're multiplying, your numbers typically get larger. Powers, the same thing. And then on the right side, we have operations that make your numbers get smaller. So subtraction, division, and taking a root of something. So how can we use this? Well, it turns out that coefficients, which are the big number in front of the variable, they do the operation that you're told to do. Whereas exponents, which are the small number in the back, they do the lower operation. So we're going to look at a couple of examples so you know how to use this. If we're starting with addition over here, we have this example, and the operation is addition. So what happens to our coefficients? If we're adding, our coefficients will add. So you look at the two coefficients here, 7 and 4, they add together to give us 11. Now, if we are adding something, the exponents are going to do the lower operation. And what's below addition? Nothing. So our variables and our exponents, they're going to do nothing, which means that they're going to stay the same, or you're going to keep them the way that they are. We can look at another example again with subtraction. So if we're dealing with subtraction here, the operation is subtracting, and that means the coefficients are going to subtract because that's what you're expecting them to do. And then you see that happen here. So 7 minus 4 will give us the coefficient of 3. And the exponents, being that smaller number, they're going to do one operation below, which is nothing in this case. So below subtraction is nothing on our pyramid. And so since they do nothing, we pretty much keep them. We can look at another example with the product of powers rule. So that's when you're multiplying. And when we're multiplying, our coefficients do exactly what we say. If we're multiplying, they're multiplying. But the exponents are going to do one level below that, which if you look under multiplication is addition according to our pyramid. So in our example, we notice that our coefficients, 3 and 4, they multiply together to give us the coefficient of 12, and our exponents, 2 and 7, will add together to give us the exponent of 9. Okay, I bet you can guess what's happening next. So for division, if we are dividing, notice we have two representations of division here, one using the division symbol and the one using fractions, but in either case it works. If we're dividing, our coefficients will divide. 20 divided by 5 gives us 4. And our exponents, they're going to do one level below division, which is subtraction. So our exponents are going to subtract. So in this case, 10 minus 3 will give us the 7. You have to be careful though of the order. So just as it's 20 divided by 5, top divided by bottom for the coefficients, the exponents are going to be similar, and that it's going to be 10 subtracted by 3, so top subtracted by bottom. And last but not least, when we're dealing with powers of powers, so we're taking a term that has a power in it, a variable with a power, and we're raising it to a power, what do you think is going to happen? Coefficients will do exactly what we say. So if we are squaring in this case, the coefficient 3 is going to get squared. 3 times 3 will give us the 9. And that's because we're taking powers. What's the operation right underneath our powers? It's multiplication. So what do you think the exponents are going to do? They're going to multiply. And we see that here. The exponents 5 and 2 will multiply together to give us 10. So what we're going to write here is for the coefficient raised to the power, and unfortunately this got cut off in the video, but above exponents, you're going to write multiply. Finally, we're going to do one more, and the last one is roots, and you pretty much guess what's going to happen. We're taking a cube root of 125 times x to the 6th power. So our coefficients do exactly what we say we're going to do. The operation is taking the cube root. We take the cube root of 125, which gives us 5 for our coefficient. And for the exponents, what's underneath roots? Division. So notice what happens here. Our exponent 6 gets divided by 3, which gives us 2. Again, with the case of taking the roots, we have to be very careful about which one we're dividing. So it's the inside power that's divided by the outside power. And you can always check this by doing the inverse operation. So if the cube root of 125 times x to the 6 is 5x squared, then if you were to take 5x squared and multiply it by itself 3 times, so 5x squared times 5x squared times 5x squared, that should give you 125 times x to the 6th power. All right, I hope you've enjoyed this video. Don't forget your Delta Math practice. Have a quality weekend.